Hello, today we're going to be looking at finding the domain and range from a graph. So these graphs are a little different than the other domain and range things we've looked at because, as you can see, like for instance, looking at this first one, this line segment is continuous. All the points are connected together. You don't have individual points. And some of them, as we scroll down here, will have arrows on the ends. That's a little different, but it's the same idea. Our goal here today is to be able to find the domain and range from looking at a graph. So far when we've done domain and range, we've listed individual values and we've written them. I'm going to write this as an example, but immediately get rid of it. We've written our domain like this, just as individual values with commas in between, curly brackets at the beginning and end. Same thing with the range. However, when it's not individual points, but it's a continuous graph like we see here, we have to write our domain and range a little bit differently. I'm going to walk you through that today. The idea behind domain and range is still the same. Domain is the x values your graph covers. So let's look at this first graph here with the line segment. The smallest x value my graph ever hits, which is right here, which is at x equals -3. The largest x value my graph ever hits is right here, which is x equals 0. So the way that we write our domain here, since it's in between -3 and 0 only, is as a compound inequality. It's going to look like this, but we are going to fill in -3 and 0. So my domain is going to look like -3 is less than or equal to x, which is less than or equal to 0. Another way you can say that out loud would be x is between -3 and 0, including -3 and 0. So when you have a graph that does not go on forever and ever, we write our domain and range like that. Now we're going to do the same thing with the y's, because our y values talk about our range. So my range is my y values. Looking at my graph here, the smallest or lowest y value my graph covers, that y value is 0. The largest y value my graph covers is at 4. So I'm going to write my range the same way with those less than or equal to signs, y in the middle. My smallest y value goes first, so 0. My largest y value goes at the end, which is 4. So my range is between 0 and 4, including 0 and 4. Next one is very similar. We have a circle instead, but that circle isn't going to have arrows making it go on forever and ever. So there's going to be a definite starting and stopping point to my domain and range. The smallest y value my graph ever covers, x value my graph ever covers is at -4. The largest x value my graph ever covers is at +4. So my domain is x is between -4 and +4. Like that. Or -4 is less than or equal to x, which is less than or equal to 4. Same idea for range, but now we're looking at the top and the bottom of the graph. The lowest y value my graph ever covers is y equals -6. The largest y value my graph ever covers is 2. So my inequality is going to be -6 on the left, y in the middle, and 2 on the right, like so. So just to kind of clarify before we go on and on, domain is talking about the left and right side of your graph. Range is talking about the top and the bottom, because x goes left and right, y goes up and down. Let's try this triangle one. So I don't have things labeled here. Let's just assume that every block is worth 1. So here would be 2, here would be 4, here would be +2 for y's, here would be 4 for y's. Okay, so let's start with our domain, our x values. Here is my leftmost x value. The x value there is 1. Here's my rightmost x value, my biggest one. That x value is 5. So my domain, all of my x values are between 1 and 5, including 1 and 5. So I write my inequality like so. Now let's try our range. My lowest y value is here at the bottom of my triangle. That y value is 0. My largest y value is at the top of my triangle, which is at y equals 4. And so my range is going to be, my y values are all between 0 and 4, inclusive. So before we do any more, if we have definite starting and stopping points to our graph, our domain and range are going to look like these compound inequalities where you have x and y kind of sandwiched in the middle. Your smallest x or y value on the left side, your largest x or y value on the right side. The rest of these are still going to be graphs, but they're going to look a little different. Either they're going to continue on and on in either the x or y direction or in both the x and y direction. So let's start with these. These are called parabolas here. This is what happens when you graph a quadratic. Let's start with this parabola right here. We are going to be using a combination of these two ideas here. So let's start with x values. X values is left and right. It goes on forever and ever pointing this way. So it continues to the left forever. But the biggest x value my graph ever crosses is x equals 6. So my x values are 6 and everything smaller than 6. So the way we're going to write that is like this right here. My domain is going to be x is less than or equal to 6. 6 is my biggest x value with all the x values smaller than that as well. We never touch anything. Our graph is never going to cross beyond x equals 6 here. So it's only 6 and smaller for my domain. Now let's look at our range. So it's happening very gradually, but eventually this will keep pointing down forever, and this arrow will keep pointing up forever. So we are going to cover every single y value possible eventually if we made our graph infinitely big. So since we will hit all possible y values, we're going to say all real numbers here for y. This next one is also a parabola, but notice it's rotated. It's in a slightly different spot, and the way the arrows are pointing is rotated. So our domain and range are going to be a little bit different this time around. Let's talk about domain, looking at the left side and the right side of the graph. This arrow will eventually continue to the left forever, gradually. This arrow, if we kept our graph going, would keep going to the right forever. So we are going to hit every possible x value eventually. So that means our domain this time is all real numbers. Now let's look at our range being y values. I have a definite bottom to my graph. So this is y equals 3. And if I follow my arrows, they will keep going up forever. So my y values are from 3 on up. So the way we write that as an inequality is going to be y, it'll be like this. Y is greater than or equal to 3. 3 is my smallest y value, and it'll continue to go up from there. The last two are similar to each other. Notice that we have arrows on both ends, but it's not a parabola. We've got a line here. We've got a cubic function here. The same idea, though. Let's look at our x values and our y values for our domain and range. My x's, this arrow will continue pointing to the left forever. This arrow will continue pointing to the right forever. So since it's going to point to the left and right forever, my domain is all real numbers. Now what about our range? This arrow will continue to point down forever. This arrow will continue to point up forever. So my range is also all real numbers. So it's possible for your domain and your range to both be all real numbers. That happens if you have a graph that'll continue up or down forever, as well as left or right forever. Whereas back here, let's look at those parabolas again real quick. There was a definite biggest or smallest x or y values. That's why we had those inequalities there instead. All right, last one. Let's look at our domain, our x values. This arrow here will very slowly but eventually point to the left forever. Same idea here, but to the right forever with this arrow. So my domain is all real numbers. Now let's try our range. This arrow will point up forever. This arrow will point down forever, so eventually we'll hit all of our y values. So my range is also all real numbers. So let's kind of retrace our steps here, finish things out. If you have definite endpoints, then your domain and range are going to be these inequalities with your x or y as a sandwich in the middle. Smallest x values on this, or y values on this side, largest x or y values on this side. If you have a graph that points forever in one or both directions, that's where we include all real numbers. If you have a definite starting or stopping point to your x's or y's, that's when we involve things like x is less than or equal to 6 or y is greater than or equal to 3. That is it for today. I hope you have a fantastic day.